In this video, we're going to look at how to solve a system of equations. So in part A, we're given two equations, both with x and y. Notice that the coefficients of x in both of these equations is 1, and the coefficient of y is 1. Generally speaking, when we go to use substitution as a method of solving, it's generally easiest if there is at least one variable with a coefficient of 1. Now we have 4 different choices, so we could choose any one we want. What I'm going to do is I'm going to use the first equation, and I'm going to solve the first equation for y. So let me just rewrite this. So I'm going to solve this for y. I'm just going to subtract x on both sides. And we have y is equal to 4 minus x. So anywhere I see a y, I could substitute 4 minus x. Anywhere I saw a 4 minus x, I could substitute a y if that was the case. So now I'm going to go into the second equation, and I am going to substitute 4 minus x in for y. So anytime I substitute, I always substitute into parentheses. And one of the big reasons I do that is because of this situation that arises in this problem. So we have a negative sign out front, or a minus sign, and we have to remember that this statement says x minus quantity 4 minus x. Or another way of thinking about that is x minus 4 minus negative x. And notice I like to think of this as distributing that negative sign. So this would be rewritten as x minus 4, x minus negative x equals 2. And remember, anytime we have two negative signs, that's just going to be thought of as a positive. So now I'm going to solve this equation. I'm going to first combine like terms on the left. So that's 2x minus 4 equals 2. Add 4 to both sides. That's 2x equals 6. Divide both sides by 2. And we get x is equal to 3. So that's half my solution. Remember, when we are solving a system of equations, we're looking for the point of intersection. And a point of intersection consists of an x coordinate and a y coordinate. We just found the x coordinate. Now I'm going to take that x equals 3 and I'm going to substitute it back into either equation. Okay, so I could plug it back into the first equation. That's x plus y equals 4, so I could substitute 3 into this equation and solve this, which is what I'll do right here. So we get y equals 1. And now my solution is the coordinate 3, 1. And I'm done. But be aware, I could have taken the x equals 3 and I could have substituted it into the second equation instead. Excuse me. So if I do that, I'm going to just solve this. We get negative y is equal to negative 1, so that means y is equal to 1. And notice, I get the same answer, same coordinate, 3, 1. At this point in time, once we've solved the system, we should go back and check our solution in both equations. So let me write down both of the equations here. And I'm going to substitute 3 in for x and 1 in for y, and we should get a statement that is true. In this first equation, we get 3 plus 1 equals 4. That is true. In the second equation, we get 3 minus 1 equals 2, and that is true. And just for the record, I always encourage everybody to substitute into parentheses You just write those in there just to ensure that everybody keeps good habits. So we get true statements in both equations, so that means that the solution that we got 3, 1 is correct.